Hello everyone. As you see from the title slide, our project is about developing an artificial intelligence system for identifying good drill sites for boreholes and so increase the access to water resources. I'm a co-director of the HydroBlu company, and the other co-director is Mr. Josh Kiston, also present here, and he will also answer your questions. Around the world, 2 billion people are still using contaminated water. In South Africa, more than 70% of our people depend on groundwater, and the cost of drilling just one borehole is about 100,000 rand. The quality of a drill site is not guaranteed, and even if it's completely dry, this is the amount that still has to be paid to the service provider. There are 12,000 boreholes in South Africa that are non-functional, and that's not even counting the dry ones. If the site selection is only 25% accurate, this is a loss of about 1 billion rand, not to mention a loss of access to water. This project concerns application of machine learning to increase the accuracy of identifying a drill site. Hydrogeologists identify drill sites from indicators like soil type, information about the water table, and so on. However, much more data is available through global information systems. Increasingly, we have access to more data sets such as the Google Earth Engine, the NASA Earth Data Project, and the Esri Living Atlas. Each set supplements the data available at geolocations around the world. When you combine that with available data about the quality at previously drilled sites, you can develop a model that can predict this quality. Currently, our own machine learning model is determining with an accuracy at the 90% level, and our model improves itself with further training as more data becomes available. This slide shows how the system is set up. We wrote an application programming interface, or API, which is a way to draw data from the 3 datasets listed here. The API converts the data to a common format and integrates the data we've collected on both good and bad borehole drill data. We're then ready for analysis. You can imagine the dataset as a massive table, with most columns being input features and some columns being about borehole quality. The next step is to identify which input columns correlate most with the output. So from a list of perhaps 50 variables, we cut it down to the 10 most relevant features. We can use techniques like singular value decomposition and principal component analysis to do this. We are then ready to train our machine learning model. There are 7 popular models, including the obvious candidates like neural nets, identification trees, Bayes belief networks, and nearest neighbors. We then split the data row-wise into a training set, a validation set, and a testing set, and we train the model. From the validation and testing done so far, we've developed models with an 85 to 90% accuracy level. Here's the value proposition. Given that there are 35,000 boreholes drilled annually, if we assume only a 2% market penetration at 85% accuracy, we would create a saving of about 60 million rand. Setting the subscription level at 10% of this estimated saving, we anticipate income at 6 million rand per annum. These figures are very conservative. We believe that for the accuracies we are reporting right now, a 2% market penetration can be easily increased. It should be noted that in our projects we use the serverless paradigm, which scales easily. So once we're up and running, increasing the number of subscribers can be done with very little increase to our costs. This one shows our progress. We've already mentioned our accuracy levels, and we plan to start field testing in December. We are funded by the Technology Innovation Agency, and we are finalists in the Africa Artificial Intelligence Expo and the Africa Cup Innovation Summit. This slide shows what's needed to go to the next level. Besides the obvious marketing, business, and legal compliance requirements, there are some steps we need to take for offering the model as a professional service. We are creating the web interfaces and back-end server operations needed for a subscriber to sign up and start using the model without much assistance. Technical documentation, user guides, and training videos are also needed. The relevance to COVID-19 is shown here. We all know that comorbidities increase the risk level when exposed to COVID. We have real water-related diseases in our country due partly to the limited access to water by more than 70% of the population. Better access leads to better health and the reduction of all diseases, not just COVID. In addition to better health, easier access to water leads to better hygiene, which again lowers disease transmission and overall brings a more dignified human existence. Thank you kindly for listening.